All right, the number of participants seems to be stabilizing, so we're going to get started. Hello, I'm Mark Coleman. I'm the Cloud Native Computing Foundation Marketing Chair. Today, we've got the Prometheus 2 release webinar, and we're joined by Brian Brazel from Robust Perception and Ben Kochi from GitLab. And as a CNCF webinar first, we also have Thingy the cat, apparently. Slightly off camera there. There we go. Hello, Thingy. So before we jump into it, a couple of things. As some of you will know who joined us earlier, we used to do all the questions at the end, but these days we encourage you to ask questions throughout the webinar. You can't actually talk, so just drop them into either the chat window or the Q&A box, and we'll find opportune moments to interrupt the presenters and ask them those. Now that's all that's left for me to say is Brian and Ben, the Thingy, are you ready?
Yep.
Take it away.
Yep. Thingy decided he was done with the webinar, so he wandered off.
Bye-bye, Thingy.
Cloud native, not cat native.
Correct.
So thank you all for coming. So as stated, I'm Brian Brazel, and we've got Ben Kochi there. We're going to talk a bit about Prometheus 2.0, which was released just over 3 weeks ago. So in this webinar, I want to look at, give some background about what Prometheus is, and then as well looking at Prometheus 2.0, what's changed, what's improved, and so on. So to give some general background, Prometheus is a time series-based monitoring system. That means it doesn't deal with logs, it doesn't deal with traces, it doesn't deal with profiling, it deals with time series, just with numbers. And it's designed to work well with cloud-native environments such as Kubernetes. So if you have a very dynamic setup with lots of infrastructure, lots of applications, lots of releases, Prometheus can handle that no problem. Because Prometheus at its core has a data model which uses key value labels that are associated with every time series. And then we have our own language called PromQL that allows aggregating across this, joining, doing simple prediction in any way you want. So you can aggregate across application, across data center, across environment of prod versus development. Any query you can reasonably think about, you can do with PromQL because it's pretty powerful. So if you can subtract things, divide things, whatever you want. And this is pretty handy because as well with PromQL, it isn't just for graphing, for which we would normally recommend Grafana rather than anything built in Prometheus itself. Anything you can graph, you can also alert on. So there isn't a big division between graphing and alerting. It's all the same thing in Prometheus. We also, in addition to Prometheus, have a component called the Alert Manager, and it will take in alerts from multiple Prometheus servers, group them together into notifications. So you're not getting one email or one page for every single instance down. You might get just one page for an entire service being down, which really helps improve signal-to-noise ratio and makes it faster for you to resolve your issues. And it also has a whole pile of integrations with Slack, VictorOps, OpsGenie, PagerDuty, HipChat, email. There's about 12 of them. And lots of third-party options as well. So Prometheus can handle both graphing via Grafana and all the alerting via Alert Manager. There's a question then of how do you get data into your Prometheus? The best way is to use a client library. We have them for 13 or 14 languages, which covers basically everything. So like Go, Ruby, Java, Python, and then there's unofficial ones for Haskell, Bash, .NET, everything's covered. And you use then to instrument your code for the things that are most important for you, both technically and from a business standpoint. If you want to track the number of orders that customers have put into your system per second, that's something you can do with Prometheus. And that's normally only 2 or 3 lines of code. So it's pretty simple. For more infrastructure stuff where you cannot change the code, there are over 200, probably over 300 by now, integrations to expose metrics from basically everything there is. So we've got things like CAdvisor for all your container stuff, MySQL, Postgres, Oracle for all your database stuff, SNMP if you've got network devices, Linux and kernel stats for all the Unix systems. There's also JMX Exporter for Windows, Cassandra in all your databases. And some people have also hooked into things like Minecraft and Factorio because they really care about how many FPS they're getting because they use way too many mods. But monitoring can go beyond just the normal thing because Prometheus is very flexible in what it can monitor. Because Prometheus is designed as an open platform. So Prometheus tend to be the core of your monitoring system that you can then hook into as you want. So you can write your own exporter if one of the 200 existing ones doesn't do what you want. If you're not using a system like Kubernetes or AWS or GCE or Azure, and you have some other way of scheduling your things, you can have your own service discovery integration spinning out JSON. If you want to have something for long-term storage, once again, we have APIs for all that you can hook into, and it's all there because we know that we ourselves cannot implement everything, but we can offer our users the hooks they need to implement whatever they like. Another key value of Prometheus to talk about is reliability, because this is often something that comes up. Prometheus is designed with reliability as one of the most important things to have, because at the end of the day, it is your alerting system that's going to be waking you up when there's a real problem. So for that reason, we avoid clustering. Instead, every single server is standalone, and it only depends on local disk and the network so it can actually monitor things. And this is all designed so that you can set things up without a single point of failure. So if you want redundancy in alerting, you just run 2 identical Prometheus servers, which will both go to the alert manager. The alert manager uses some AP clustering. So then even if you lose an alert manager or you have a network partition or lose a Prometheus, your alerts will keep on working and you'll still get paged, assuming that enough of your network is in place for it to be possible for one of the alert managers to still be working, which is pretty neat. So that's a general overview then of what Prometheus is, in case you weren't aware. So I'm going to go now into 2.0. So historically, Prometheus was created within SoundCloud because there were scaling challenges with some of the existing monitoring systems using things like statsd, and that was a moderately dynamic environment. But in the last 3-4 years, call it, with the increase in Docker, containers, and things like Kubernetes, the profile of how users are using monitorings and managing their systems has changed. We've gone from a situation where you might have 100 or 1,000 or even 10,000 VMs, but they're static and live for a long time, where a long time is weeks at least, to where you might be deploying new pods on Kubernetes several times an hour. And this means you're creating and destroying a time series a lot, because every single one of those has a pod ID on it. And that causes performance issues in the previous Prometheus design. Because in Prometheus 1, we were using a file per time series. And that causes problems when you have lots of churn. So the big change in Prometheus 2 is the new storage engine, which is indeed our Turd storage engine. And it is a brand new design. It's based on time-based blocks, normally for about 2 hours. And there's been a lot of optimization done. So in all, we're seeing typical numbers from users that RAM is cut by 3 to 5x, CPU usage similarly, and IOPS are down by like a factor of 100 commonly to, well, basically nothing, which is great. And as well, because it's using inverted index and these posting lists within each 2-hour time block, it means it can handle the churn that's happening we're seeing in all these cloud-native environments with a lot of changing of time series. So that's great for scaling out over time. As well, it's using page cache to store everything. Prometheus 1 was doing its own memory management on top of what the kernel was doing. In Prometheus 2, we're just relying on the kernel because, well, Linux has been doing this for well over a decade now. It knows what it's doing. There's no need for us to second guess it. And another thing to consider is that some users like to take backups of Prometheus. In Prometheus 1, this wasn't really practical because it involved shutting down Prometheus, which might take a few minutes. Now in Prometheus 2, you can do it in a few seconds, and it's much more efficient, which is handy for the users who care about that. The second big change after the storage engine, I should of course mention Fabian, who basically developed the storage engine, is then staleness. So a long-standing issue, in fact, one of the longest issues that we had in our bug tracker was around staleness. In Prometheus 1, if you had a time series and it went away, such as the Kubernetes pod went away, Prometheus would continue to return that for 5 minutes afterwards, which causes a bit of problems if you're trying to, for example, alert on that going away, because it's going to add a 5-minute delay to that. And it also can cause double counting if, for example, another pod comes in to replace it, and they're both in there inside that 5-minute window. So in Prometheus 2, this is no longer an issue because Prometheus will now notice that the target's gone away, mark it stale, and no longer return it. So this is something pretty nice that most users will just get for free. Another change is rules. We now have rule groups. Previously in Prometheus 1, all the rules you have, so recording rules allow you to execute a query and save the result inside Prometheus. So it might be called standing queries or whatever. And this is commonly used for aggregation. And historically how it worked is that all the rules you had was just one big block and they were all run simultaneously. So there were race conditions there as to whether you were getting the information from a previous run or the current run, or maybe a mix of those two. So in Prometheus 2, we now have the notion of rule groups, and you can have multiple groups. Each of them has a list of rules, which are just run from top to bottom in order. So you can now have dependencies between your rules in the same fashion. And if you have some rules that are doing an aggregation hierarchy, that's great, because they now can depend on the property and save yourself some CPU. Another more minor change, but just for consistency, is that the rule format is now YAML, because that's what we ended up using standardizing on in Prometheus. And it's much easier to work with programmatically, as well as easy to convert using Prometheus if you've got existing rules. So
one more thing on rules that's really handy is the rules can now have individual, or the rule groups can have individual execution cycles from intervals, so that different rule groups can be done every 5 seconds or every minute or every 5 minutes. And this allows for some interesting techniques to do internal downsampling. Of course, the Prometheus server won't store these for a longer period of time, but you can use federation or remote streaming to send these downsampled metrics to an external server.
Yep. So then just to summarize, so the main things in Prometheus 2.0 is new storage, which is much more efficient and scalable, the improved staleness semantics, and the improved rules. There are some other additional small changes, like some modifications to PromQL, but the big changes are there. But the important message to get from this is Prometheus is more ready than ever to be able to deal with Kubernetes and other cloud-native environments as they continue to be rolled out. Do you have anything more to add, Ben?
No, and it continues to work for traditional environments. It's not just for cloud-native environments. It scales super fantastically for large systems, and the new performance improvements are just significantly nicer on your computational resources. So the 10x to 100x improvement in storage, or like, for example, 100x improvement in IO means that you don't need as big a Prometheus server to monitor a large number of systems.
Great. So I guess now's the time to ask if anyone has any questions.
Hello. I don't see any in the chat yet, but I think since Prometheus already has a large and growing community of current users, there are going to be some questions about upgrade paths. How does that look for getting to 2.0?
Yeah, so there's a few different options for this. The biggest one we recommend is starting up because of the polling method of Prometheus, you can have multiple Prometheus servers running simultaneously, and our recommended upgrade technique is to set up a second Prometheus 2.0 server in parallel with your existing server. This makes it really, really easy to test and verify that everything you expect to be working with Prometheus 2.0 with your existing 1.x server is working as expected. You're getting alerts sent, you're getting the graphs generated, all this data is being collected, and you have no performance problems. And then once you've got some testing on that, then you can simply just throw away the old Prometheus 1.0 server and continue on with 2.0. There's also a couple of different people in the Prometheus community who have developed or are in the process of developing database conversion tools. They're kind of a work in progress. Of course, it takes quite a long time to convert a database, so it may take longer to convert the database than to simply set up a new one and wait. But if you have a very small database and you want to just do an offline upgrade, there are a couple of tools being developed for that.
Thanks, Ben. I think also a relevant question would be, since we've got Cloud Native Con coming up next week, there's probably going to be a whole, I mean, I haven't checked, but there's probably going to be a bunch of Prometheus content there that people should look out for. Are you aware of any tips for people who are flying over to Austin?
So there was actually just a few minutes ago, a post went up on the Prometheus blog detailing the sessions to look out for. I know there's a Meet the Maintainers session and a project salon off the top of my head. But if you go to Prometheus.io, just check the blog link, it'll be the top post there.
Cool. I'll go and find that now. In the meantime, I think there's a new question in come through the Q&A. Ben, can you grab that one?
Sure. So the question on the Q&A, first one is, are there any guidelines for production deployments in the cloud? Basically, do's and don'ts. Most of it is, that's a good question. There are a bunch of recommended best practices, mostly around metrics and instrumentation, and not just for deployments. But yeah, on the Prometheus IO website under the docs directory, there is some best practices. I think we probably could do better on this and have some more official like deployment best practices, especially around how to get the data into, or how to schedule things. Next question on the thing, is there IPv6 support? Yes, IPv6 is totally fine. You can fully supported.
Yeah, I think we managed to squash all those bugs. Okay.
In the meantime, I dropped the Cloud Native Con highlights for Prometheus that Brian mentioned. They're now in the chat. So if you're coming over to Austin, check them out there. And I think there's a couple more questions come through.
Yeah, I'll just grab another one. So there's a question there asking about legacy application monitoring on 500-600 machines where they change the code base and it sounds like it's a Java application. So in that sort of situation, there is the JMX Exporter, which I maintain, which can get all your standard Java stats. So all your memory pools, your thread pools, how many classes you have loaded, the Java version, in addition to the process stats like CPU used, memory used, file descriptors. So that can be attached as a Java agent, and you'll get all that stuff. And in addition, if there are any mbeans for JMX, you can also extract them out that way. So basically use the JMX Exporter as an agent and it'll take care of you.
Excellent. That's 3 down. I'm seeing one more from Ampreet.
Yeah.
So
I can try that one. So the question is about histograms and how to graph them in Grafana. So I'm not familiar with these particular ones here, but I can talk about Prometheus histograms generally. So the general answer is that you get the histogram, you aggregate it up, keeping the LE label, and then you call histogram quantile on that to get your 99th percentile, your 75th percentile, whatever else. And then you graph that directly in Grafana just as would everything else. Now, Grafana did also, a release or two back, add in a heat map. However, it does not yet support Prometheus because Prometheus's histograms are cumulative and it doesn't support that yet. But I believe they are working on that. So I hope that answers that question.
All right, thanks, Brian. It seems that those were the only questions that we've got right now. I'm just going to check the chat. No, there's nothing else in there. So there's all that's left for me to say is thank you very much to Ben, Brian, and of course to Thingy the cat. That was a short but sweet presentation, and I'm sure if you need more information, you can just go to the URL that you saw with the blog there and follow it up to the top and find everything else you need. Otherwise, I hope to see you all at Cloud Native Con in Austin next week for one of those Prometheus highlights. Ben, Brian, thank you very much.
You're welcome.
You're welcome.
Have a great evening, everybody. Bye-bye.